Hello, for Project 6, we chose to make the video on periodic functions. And to give it a definition, this is a function that returns to the same value at regular intervals. And we see this many times in our life, and some practical uses would be measuring tidal waves, EKGs, and other instances like that. Our group thought that trigonometry and reviewing the unit circle would be particularly useful when you are working with periodic functions. Trigonometry is the function of angles, and for our sake, we focused on sine and cosine because all of the other functions were based off of those two. And then the unit circle is also useful to review before you start working with periodic functions, particularly the fact that the circumference is 2 pi, and this is useful when you start working with the period of periodic functions. Alrighty, next we have the two important equations that we look at, and since periodic functions are a function of time, that is why we have t in the parentheses for f of t and g of t. You can see they have similar components, and A, the amplitude, tells you the midway between the maximum and the minimum, and the way you find that is by subtracting the minimum from the maximum, then dividing by 2. Next, you want to find the period, and this is how long one complete cycle is. Once you find that minimum, you put it under 2 pi, and if you can simplify. Next is C, and this will tell you the vertical shifts of the graph. So if the graph does not start at 0, that is a vertical shift, and the way you do that is by adding the maximum and the minimum and dividing by 2, or in other words, finding the average. And then where you see t minus h or t plus h, this will tell you if the periodic function is shifted to the right and by how much. Here I show you the difference between a sine and a cosine periodic function. The one in magenta is a typical cycle for sine, and the bright pink is a typical sine for cosine. Periodic functions are useful in real life, and I will be going over our real life example that shows how the two tides that are experienced during a day are an example of a period function. What many people do not know is that there are oceanologists that will graph all this data and make predictions depending on the gravitational pull of the moon. And this is one example from an island in Puerto Rico. With the periodic function given, I will teach you how you can graph this from time 0 to 24, and I will teach you how to find the water level at the high tide and what time low tide was. I will also show you how to find period of this particular function and be able to interpret that. And we will also be finding the amplitude and interpreting that in tides in terms of the tides. By using the equation given in the slide before, you can use the amplitude and the vertical shift to find the maximum and the minimum. What you do is add 4.9 and 6.3 to find the maximum, then subtract 6.3 from 4.9 to find the minimum value. Other information that we got from the function was that the period was pi over 6, and we know that if we multiply each side by 2, we get 2 pi over 12. So this tells us that a period or a full cycle is over 12 hours. So we know we have 2 cycles in 24 hours. For part B, when they ask us to find the maximum value, what we did was add the amplitude and the vertical shift. 4.9 plus 6.3 is equal to 11.2. The next question asks us to identify the hours in T after midnight that the tides are at the lowest. So what you do is find or follow the x-axis and see when the function hits negative 1.4. And in this situation, the time is 6 hours after midnight and then 18 hours after midnight, which is also at 6 a.m. and at 6 p.m. For the next question, we can figure out how long the period is if we remember that we find it when we put 2 pi over b. And since our function shows us pi over 6, we know that we have to multiply the numerator and the denominator by 2. When we do that, we get b equals 12. And this tells us that the period is 12 hours, and it shows us how much time passes between successive high tide. For the final part of this question, you can always identify the amplitude by looking at the number that is in front of either sine or cosine. In this situation, it is cosine. And this number is 6.3 feet. When you are interpreting amplitude, this tells you how much distance is between the high tide and the low tide, or the maximum and the minimum in any other example.